All right, so just quick review of stuff we've already talked about. You got to be able to label the diagram of the endocrine system. Okay? Got to be able to label the diagram. So we've got up in your brain the two structures that control the endocrine system, which are what two structures? Hypothalamus and the pituitary. We said that was like the Emperor and Darth Vader, right? Hypothalamus and the pituitary. Back in the back of the brain, we've got the pineal gland, which helps control your what? Sleep-wake cycle, your what kind of rhythms? Circadian rhythms, your sleep-wake cycle, your activity levels. All right, in the throat, we've got your thyroid gland, which makes a hormone called thyroxine. What does thyroxine control? Your metabolic rate, how fast you use oxygen, how fast you do cell respiration. Thyroxine, and that hormone is one of the few hormones that affects which cells? Just about everyone. Okay, most hormones don't, right? What's a typical cell called that's affected by a specific hormone? It's a target, and it's only a target if it has what? The right receptor. Okay, most every cell has receptors for the thyroid hormone, thyroxine, because they have to be able to do what? They have to be able to do cell respiration, so they have to have what? They have to have ATP. Something else I was going to say there. I'll come back to that. On the back side, the posterior side of the thyroid are some other little glands called the parathyroids. We'll get to what they do in a few minutes. The thymus we know helps to mature your T cells, parts of your immune system. T cells are responsible for what immune response? Mostly, well, the helper T's are involved in the whole thing, right? They help to stimulate like antibody-mediated immunity, and what's the other one? Cell-mediated immunity. But the killer T's, the cytotoxic T cells, they're involved in cell-mediated immunity, which kills what? Your own cells that are what? They're infected. Sick cells. One other just reminder about some stuff. This is stuff people miss a lot of times. Primary and secondary immune responses. Primary means what? The first time you get a particular germ. What's your immune system like the first time you get a particular germ? It's kind of slow. It's got to find the right helper T cells. It's got to find the right B cells that will fit to that way. It's got to find the right ones that will fit to what? So what do those cells have to fit to? The receptors on the helper T's and the B's have to fit to the antigen, right? Protein. It takes a while to do that, and then they have to clone themselves and get activated, and B cells have to turn into what? Plasma cells. They have to start making antibodies, but some of those B cells don't turn into plasma cells. Some stay behind as what? Memory cells. So after you get over that infection, years, months, however later, if you get that same thing, what happens the second time around? It's secondary immune response, and it's what? It's fast and big. You get this huge influx of antibodies, very, very fast. So fast you never even what? Never even get sick. And that's all started by what? The secondary immune response is started by what? Well, you get the antigen, but what actually triggers the secondary immune response to start? The memory cells. The memory cells. That's important. The other glands we'll mention here quickly, the adrenal glands. You got the pancreas. The pancreas makes most of your digestive enzymes. Almost all of them. Where do those digestive enzymes work at? Small intestine. So that's exocrine. Exocrine are glands that make stuff, but send them to where they go by what? By duct, by tube. The pancreas is both. It's exocrine and endocrine. Because it makes two important hormones that it secretes directly into the blood. And those are insulin and glucagon. Insulin lowers blood sugar. Glucagon raises blood sugar. They help to keep blood sugar levels in what? Okay, give me more science word for that. Homeostasis, equilibrium. One thing I'll mention here about enzymes, the pancreas makes most of them and dumps most of them in the small intestine. What's the pH in the small intestine like? It's nearly neutral. Not much digestion happens in the stomach, but a little bit does. What substances get digested in the stomach? Well, there is hydrochloric acid. Proteins start to get digested in the stomach. Because what do we know acids do to proteins? Denature. You also have one of the rare enzymes in your stomach called pepsin. That enzyme, PEP, where have we seen that PEP before? Polypeptide, peptide. It's an enzyme that helps to digest proteins in your stomach. Most enzymes in your body, what's their optimum pH? Most enzymes work at what optimum pH? 7.35, right? Can that be the case for Pepsi? What's its optimum pH? 2-ish or something. Really, really acidic. Remember, PEP means protein found in the stomach. Moving on from the diagram, remember that the endocrine glands are ductless. Hormones go straight into the blood. They help to maintain homeostasis, control reproduction, cause you to make milk, cause you to enter puberty. They do all kinds of things. Also remember that hormones are mostly made out of proteins. Most hormones are proteins or amino acid chains. A few are steroids. But most of them have receptors that are on the outside of the cell. To work, this is that cell communication stuff. One more time. We've seen it about 100 times already. To work, a hormone has to bind to a receptor. And we're going to go through this one more time. We know that if my picture here is a picture of a cell, that's its receptor. That receptor is usually going to be on the outside of the cell. If a hormone binds to that receptor, that is step one of our cell signaling pathway called reception. Ligand binds to receptor. When that happens, what does that trigger that protein receptor to do? Conformational change. It changes shape. And once it changes shape, that triggers something to happen inside here. It may trigger G protein to get turned on. It may trigger it usually triggers a whole cascade of things to happen, all right? What is that cascade of things that it triggers to happen? What's step 2 of cell signaling? The signal transduction pathway, all right? Step 2. And remember, in that signal transduction pathway, two main things happen to that signal. It gets made bigger, it gets amplified, and it gets translated. It causes step 3 to happen. What's step 3? Response. And the response is almost always to turn on or to turn off what? Chemical reaction of some kind. So for example, if this was thyroxine, thyroid hormone, and it binds to this receptor, it's going to make what start to happen more fast in here? What's thyroxine speed up? Cell respiration, metabolism, cellular respiration. So thyroxine is going to speed up cellular respiration. Make sense? Also remember that most hormones are regulated by negative feedback. Make it. When you get to a certain amount, there's a message is sent back to stop making it. Don't go any further. All that should be old stuff. Today we want to move through more of these hormones though. Let's talk pituitary for a second. We know it's sometimes called the master gland. It's connected up to the hypothalamus by this little stalk of tissue called the infundibulum. And it's really two glands in one. The back is the posterior, the front is the interior. The posterior releases hormones made by the hypothalamus. Doesn't make any of its own. Two main ones. ADH, antidiuretic hormone. helps slow down what? Urination. When would you want to slow down urination? Yeah, maybe you're in the desert and you're not having enough to drink, or maybe you're out shooting ball. Okay? And you've been shooting ball on a hot summer day, you've been playing all day, you've been sweating. Does it make sense to be urinating down a lot of water if you've been sweating all day long? No. So in that case, your body's going to release more ADH. When you start becoming dehydrated, your body releases more and more ADH, and that slows down urination. It doesn't stop it. You never want to stop it because the main reason to urinate is to get rid of what? Toxic wastes. Okay? So you still got to urinate some, but the urine's going to be more what? It's going to be more solutes and less water. Okay? It's going to get more concentrated. That's ADH. The target of ADH is your kidneys. Slows down urination, helps to keep fluids in your blood and in your body fluids.
What happens if you have really high toxin levels?
Like drinking alcohol, for example. Alcohol is a toxin. So oftentimes that causes you to urinate more. Get it out.
This woman on my crazy addiction, she's addicted to drinking her pee.
How would you become addicted to that? I've seen this stuff before, but how would you become addicted to that? That's strange. Can't be good for you. Yeah, I've heard that. There's some strange people in this world. Let's just leave it at that. Some weirdos. Alright, real quick, back up to here. Oxytocin. Not going to mention much about oxytocin today, other than the fact that in women, it stimulates the uterus to contract. It causes labor and birth. In men and women, it causes affection and arousal. Kind of leave it at that. Now let's move to the anterior part of the pituitary. Anterior is front side. The anterior pituitary makes HGH, growth hormone, which we've talked about. It makes prolactin, which causes the production of breast milk. But it also makes that whole category of hormones called tropic hormones. These are hormones that control the other glands. That's why the pituitary is sometimes called the master gland. On this slide, we went through the growth hormone part a couple times. We know it causes your bones to get longer. That's why it's called growth hormone. But the reason athletes try to use it oftentimes is it causes fat breakdown and it causes protein synthesis, muscle build up. Break down fat, build up muscle. Too much growth hormone can cause gigantism, cause you to get really, really tall. Not enough can cause dwarfism, really, really short. Yeah.
So if your parents was both short and take HGH, wouldn't that be kind of going against your gene?
Yeah. Yeah. I mean, and HGH is probably going to only work. Taking it artificially is probably only going to work to a certain ceiling. And your genes are sort of setting the ceiling for you. I'm not sure how much over that HGH is going to make you go. Moving on down here, this category over here are the tropic hormones. I'm not going to say too much about these, but I want to mention just a couple of things. ACTH is adrenal corticotropic hormone, and that stimulates a part of the adrenal gland called the cortex to make its hormones. TSH is made by the pituitary. TSH, thyroid stimulating hormone. Thyroid stimulating hormone. And that causes the thyroid to make what hormone? Thyroxine, which we know speeds up cell respiration in just about every cell in your body. All right.
Is it other called tropic?
I think they affect every cell. Pretty much every cell anyway. Then down here at the bottom, we've got two hormones that are sometimes called gonadotropins. All right, gonadotropins. Because they're tropic hormones that affect the gonads, the ovaries and the testes. FSH What do we know that F and FSH stands for? What's the F stand for? Follicle. Follicle is the egg and the cells around it, right? Follicle stimulating hormone. It stimulates the egg and the cells around it to mature and get ready to be what? Before that. Ovulated. It causes them to mature and get ready to be ovulated. It also works in men. It causes sperm development to happen in men. FSH, follicle stimulating hormone. Another one that we'll mention more in a minute, LH, that one stands for luteinizing hormone.
What did you say good for?
Okay, tropins are hormones that control other glands. So they're hormones made by the pituitary that control the gonads, the ovaries or the testes. LH is luteinizing hormone. This one's important. It causes both sexes to make sex hormones, testosterone or estrogen. But maybe more importantly, or at least more famously, this is a hormone that about day 14 of the menstrual cycle triggers ovulation to happen. A surge of this hormone causes you ladies to ovulate. LH, luteinizing hormone, causes ovulation to happen. This is showing you how negative feedback works. And it's the negative feedback of just a general hormone. Remember, there's a chain of command in the endocrine system. The hypothalamus is the boss. The emperor, Darth Vader. Okay? Hypothalamus, pituitary. The hypothalamus sends out some message to the pituitary. Hey, you need to tell your underlings to do this. You need to tell the stormtroopers to go do whatever they're supposed to do, right? Continue this bad analogy. Because what's the hypothalamus doing? What's it in charge of? What's the hypothalamus in charge of? When you hear the word hypothalamus, you should think homeostasis. So it's monitoring things. It's monitoring the balance of all kinds of stuff. When it sees something getting out of balance, it sends out a message to Darth Vader of the endocrine system saying, pituitary, you need to take care of this problem. We got a problem. Here's the problem. You go take care of it. The pituitary sends out a message to his subordinates, the stormtroopers, and he says, you guys go take care of this problem. And they go out and they take care of that problem. But eventually that problem's taken care of. And when that problem's taken care of, it's time to act. Yeah, maybe. But it's time to stop, okay? So the hypothalamus releases a hormone that causes the pituitary to release another hormone. The pituitary's tropic hormone, these are the tropic hormones right here. These tropic hormones right here go out to the target gland and cause it to make its own. Let's say this is thyroxine. Let's say that our body needs to speed up metabolism. Maybe we're outside on a really, really cold day and our body temperature is starting to drop. One way that we can warm ourselves up is what? Yeah, and related to what I was just talking about, speed up metabolism and therefore generate what? Heat. More heat. Okay? So we need to generate heat. So the hypothalamus notices that our body temperature is dropping. It's not going to let that happen because it wants to maintain homeostasis. So it sends out a message to the pituitary, a hormonal message. Pituitary, body temperature is dropping. Take care of it now. The pituitary sends out a message to the thyroid. Hey, you're the guy in charge of metabolism. Let's go. Speed it up. Generate some body heat. The thyroid releases which hormone? What's the thyroid hormone? Thyroxine. It goes out to all the cells. And it tells all the cells to do what? Let's speed it up. Okay, let's speed up cell respiration. Let's make more ATP, and in the meantime, release more what? Release more heat.
Wait,
okay?
so what does thyroxine control? Does it just control everything?
It controls cell respiration, the rate of cell respiration. It speeds up cell respiration. But eventually, your body temperature gets back to where it needs to go, right? So the hypothalamus is going to notice, hey, it's back to normal. And when it notices that, getting back to normal, it stops releasing this, which means the pituitary stops releasing this, which means the target gland, in this case the thyroid, stops releasing what? Thyroxine. And we slow down metabolism. Does that make sense? If you have too much thyroxine, what you going to be like? It's called hyperthyroidism. Hyperthyroidism, you're going to be jumpy. You see these people all the time, they're just jumpy and they have all this energy and they're just all over the place and they're talking really fast and their eyeballs are kind of bulging out and they're crazy looking, yeah. That's hyperthyroidism, and what's going to happen with their weight probably? Probably going to start to lose weight. They may eat like a horse, but still lose weight because something's going on with their cell respiration. It's happening way fast. People with not enough thyroxine, their body becomes really, really conservative. It saves every bit of energy that it can. It's like one of those cars that gets like 70 miles a gallon. Their body becomes efficient, okay? And their body's not like our federal government. If it has extra energy, it doesn't throw it away. It what? It saves it. And it saves it as what? Fat. Because they start gaining weight, because their metabolism is very slow. They're probably going to act kind of lethargic. What's lethargic mean? Just like tired and they're moving real slow. Not going to have a lot of energy.
Can you, like, isn't there a way where you can, like, make your, if you have a slow metabolism, can't you, like, train it to, like, speed up?
Yeah, what's the best way to speed up your metabolism? Getting up and doing something, okay? Exercise, and maybe more importantly, here we go, not just aerobic exercise. Like running will burn calories. It'll speed up your metabolism. But when you stop running, it slows back down, okay? How do you exercise and keep your metabolism higher? You lift weights, okay? You build up muscle, okay? Because muscle is really wasteful tissue. The metabolic rate of muscle tissue is higher than everything else. And that's one reason it's a lot easier for guys to lose weight than it is for girls. Because guys have more muscle mass naturally, right? That's what testosterone does, okay? And because we have more muscle, we're burning more what? We're burning more calories in general. Our metabolic rate's higher, and we can eat more and get by with it than you ladies can, because our tissues are wasteful. We're like a heater, okay? We're eating the food and burning it, okay? Wasting most of it, okay? Think of guys kind of like a Ferrari. You put in the gas, and it gets like 4 miles per gallon, and it just turns most of it into what? What's most of the gas in a Ferrari get turned into? Heat. The Ferrari's got to have a really big what? To get rid of all that heat. What part of the car gets rid of the heat? We don't have any mechanics in here, huh? The radiator. That's the job of the radiator. Get out the heat, okay? Get out the heat, okay? All right, this is just showing you the relationship between the pituitary and the hypothalamus. So this would be if I was standing this way. Posterior is back, anterior is front. That's just showing you some of the different hormones that the pituitary and the hypothalamus release. ADH helps to slow down urination, keep you from getting dehydrated. Oxytocin causes the uterine walls to contract. Also causes the mammary glands to eject milk. Thyroid stimulating hormone causes the thyroid to make thyroxine. ACTH causes the adrenal gland to make its hormones. Prolactin causes the milk to be made. Growth hormone causes your bones to get longer and your muscles to get thicker. And the gonadotropins. FSH again causes what to happen? Follicles to develop. Eggs to mature and get ready to be ovulated. And LH triggers what? Ovulation, the actual release of the eggs. Ovulation. This guy is a giant. He has gigantism, and this guy's an adult. It's not a baby. That guy, that's a dwarf. He's not a midget. He's a dwarf. There's a difference. What we normally call midgets have a genetic disorder. Usually it's called achondroplasia. It's a genetic disease. These people don't have that disorder. They have, notice he's all in the right proportions, right? I mean, with a midget, it's obvious there's something going on, right? I mean, their body's in different proportions than everybody else's. This guy's not. Everything's in proportion. It's just he's tiny. And he's tiny because he doesn't release enough what? Growth hormone. He's not making it the right way. Or he's either not making it or his receptors for it aren't working. One of the two. Yeah, case cut. Normally they would have kind of a manly face. He does kind of look boyish. And I don't know.
He like a baby.
Yeah, he looks small. Now this is showing you acromegalia. This is the idea that if you continue to have a lot of growth hormone after your growth plates are already hardened, you don't get taller. Your bones get whacked. They get thicker. Okay? And this is the kind of thing that was happening to Barry Bonds, the baseball player, because he was taking growth hormone injections, and notice her forehead, she's not losing hair. It's her forehead is getting longer and thicker. Her cheekbones are getting thicker. Her chin is getting bigger and wider and thicker. She wasn't taking it. She had a tumor in her pituitary. So it caused her to continue to make it.
She can get married, didn't she?
I don't know. This woman's probably like 7 feet tall because she had this pituitary tumor her whole life. The really, really tall women that you see, most of them have some kind of pituitary problem. Alright. Yeah, I know. I don't know. It's probably just when they took the picture. Thyroid gland, let's mention it real quick. We already kind of talked about it. Thyroid gland is right here in your throat. It's stimulated by TSH, thyroid stimulating hormone. TSH is made by what gland? Which gland makes the trophic hormones? Pituitary, right? So this hormone goes out to the thyroid and it says, hey, it's time to speed up metabolism. The thyroid then releases thyroxine, and that speeds up metabolism, right? In every cell. One thing you ought to know about the thyroid is that the thyroid, to make thyroxine, needs iodine. It needs iodine. It's the only place in your body that needs the element iodine for anything. And if you don't get enough iodine, what happens to your thyroid? It starts to swell. And you get a condition called what? It can be huge like this. Your thyroid, which is normally really small right in here, can get out like that. It's called goiter. And I think I have a picture of that on the next slide. I'll show you in a second. So that happens when you don't get enough iodine in your diet. Dana, you had a question though. You show me.
Well, okay, my friend was going to that.
The iodine? Probably allergic to certain concentrations. Still have to have it.
Yeah, I think she didn't know.
Yeah, it's probably just a certain concentration because you can't make thyroxine without iodine.
What?
And without thyroxine, your metabolism is going to be all screwed up. So, yeah. Probably allergic to things that may be seafood, which is high in iodine, and iodine salt.
But those people who have that, I don't know, would they look like one of those, I don't,
No,
I want to it must look like a yeah.
I'll show you here in a second. I've got a picture, I think. All right, real quick. Join me here, guys. Join me. Thyroid hormone regulates metabolism by stimulating your body to burn glucose. So it stimulates the respiration. It stimulates your body to burn glucose. As we said before, it affects almost every cell in your body. If you have hyperthyroidism, that means you're making too much thyroxine, right? Too much thyroxine means your metabolism is going to be what? Too fast. And you're going to be jumpy, and you're going to lose weight, and you're going to be nervous and fidgety and that kind of stuff. Shaky. Hypothyroidism means not enough. So your metabolism is going to be too slow, You're going to gain weight. You're going to be lethargic. You're going to move around real slow. You're not going to have any energy. Yeah.
The one that makes too much, they be considered like not OCD, but ADD, you know what it is.
They might act like somebody with ADD. Different,
ADHD.
yeah, different problem, but they might act sort of like that. They're going to be really, really active and shaky.
So those get misdiagnosed.
It's possible. A simple blood test would tell somebody about this really quick if they were looking for it.
Hey, what? Something in the middle.
Just that's just normal.
How do you fix it? Like you just.
There are medications, like for example, hypothyroidism. They'll give you thyroid hormone. They'll give you injections of thyroxine. Too much. I think they can give you drugs to slow down the production of TSH, which will then slow down the production of thyroid thyroxine. Let's see. I'm not going to go too much here. Sometimes hypothyroidism is called cretinism. It's another name for it. That should say hypo right there. Hypothyroidism. And there's also this disorder called Graves' disease. In Graves' disease, it's an autoimmune disease. So your immune system's kind of gone wacky on yourself. And you make antibodies that your thyroid gland thinks are TSH. So these antibodies, your thyroid gland thinks when the antibody's attached to it that it's TSH. And TSH tells the thyroid to what? Make more thyroxine. Make more thyroxine. Make more thyroxine. So Graves' disease causes your body to make way too much thyroxine, and you get too high metabolism. You get really nervous. You start losing weight. It's not a good condition. The last thing I'll mention here about the thyroid is the thyroid makes another hormone too, and it's called calcitonin. And it should be pretty obvious what it helps to control. Calcium levels in the blood, calcitonin. It also regulates phosphate. Where in your body are those two things imported together? The bone. The hard part of your bone is in large part, the salt part of it at least, calcium and phosphorus salts. This helps to control bone health. A big part of it's bone health too. And notice what it does. Calcitonin lowers calcium and phosphate levels by inhibiting osteoclast activity. We haven't talked about the skeletal system. What do you think an osteoclast is? Osteo means what? Osteo means bone. Okay? It's like osteoarthritis. It's arthritis in bones. Osteo means bone. Osteoclasts are cells that you have that break down bone. Turns out your bones are constantly getting broken down and then what? Rebuilt to keep them healthy and new. If bone is broken down, what gets released into your blood? Calcium and phosphorus. Okay? So osteoclasts working raise calcium and phosphate levels in your blood. You have another set of cells called osteoblast. So you got osteoclast and osteoblast. If osteoclasts break down bone, osteoblasts must build up. And if they're working, what does that do to your calcium levels in your blood? That decreases because they have to take the calcium out and use it and put it in the bone, right? So osteoclasts break bone and release calcium into the blood. Osteoblasts build bone and therefore take calcium out of the blood. This hormone, calcitonin, inhibits bone breakdown. It inhibits the osteoclast, which means the calcium levels start to drop in your blood. It stimulates osteoblasts, which means bone building starts to speed up, so that's taking calcium out of the blood. So less calcium is released in, more calcium is taken out, it drops your calcium levels. Really important in kids, because that's when they're what? They ought to be building bone way faster than they're breaking it down, right? In somebody my age, what should I be doing? I ought to be doing them at the same speed, right? Because I'm not growing, my skeleton's not getting any bigger. I should be doing them at the same speed. But somebody say Micah, he's probably still growing. And therefore, osteoblast in Micah should be working faster than osteoclast. He'll be building faster than he's breaking down. All right, there's a goiter. Yeah. Most of the time, there's several things that can cause that. Yeah, that's a nice sideburns. But the most important thing that causes goiter, the most common thing, is that not enough iodine in your diet. You never see this in the United States, at least very rarely, because what do we do in the United States to keep that from happening? Iodine is added to our table salt. You ever notice on bottles of salt it says iodized? This is the reason iodine is added to our salt, so that we get iodine and we don't get goiter. We can make thyroxine. Now, it's a problem in certain parts of the world, like the continental part of Africa, in the middle. Okay, it's not a problem on the coast, because on the coast they're eating seafood, right? And the sea has lots of salt in it, and part of that natural salt, the sea, is iodine. So that people eating seafood get plenty of iodine. But people in the middle of Africa, not near the ocean, they get iodine deficiencies, and they're likely to get goiter. All right, I guess that's where we'll stop. Let me turn this off. I'll be right with you for a second.